Hello everyone. Another paper of Pure Maths P3. This time it's October-November 2021, variant 32. Our approach will be the same. The first 7 questions in the first part of the video. The second part will consist of the last 4 or 5 questions. So now what is this question all about? First, read comfortably. We all have a habit of hastening up things, but that is counterproductive. Find the value of x. There will be one answer for which this equals to this. Give your answer in the form ln a over ln b, where a and b are integers that we have to find out. First of all, 2 raised to power of 1 minus x is 7 raised to power of x. A lot of people, they make this mistake. They start with logarithms from the beginning. And that, in this manner, if they start this way, they won't be able to get exact answers. So first simplify using indices. 3, 2 raised to power of 1, 2 raised to power of x is 7 raised to power of x. 3 multiplied by 2 is 7 raised to power of x multiplied with 2 raised to power of x. This is 6. Since the powers are the same, the bases multiply. 14 raised to power of x. Or let me swap the places. 14 raised to power of x equals to 6. Now you can either take LG or ln of both sides, but since the question is in terms of ln, therefore now take natural log of both sides. So when you take natural log of both sides, ln something, what is something on the left? That is 14 raised to power of x. What is something on the right? That is 6. X ln 14 is equals to ln 6. X comes out to be ln 6 divided by ln 14. Is it of the form ln a over ln b? The answer is yes. We don't have to state it separately, but even if we do, that's a good habit. A comes out to be 6. A is at the top and b is at the bottom. The value of b comes out to be 14. So that's a simple question of logarithm in which the answers are given in the exact form. So 6 is at the top, 14 is at the bottom. Question number 2. Again, first read, then label the question. I hope I've labeled the previous one. Solve the inequality. It's a modulus inequality. Modulus on the left, modulus on the right, and a is a positive constant. So this is mod inequality. And the first question was basically about indices and logs. So now, since you have modulus on both sides, the easiest method is square both sides. So this is according to the case, the order in which the cases I have taught. This is case number 3, square both sides. So therefore 3x minus a, the whole thing square, is greater than 2 and x plus 2a, the whole thing square. Therefore, this is 9x square minus 6ax plus a square, that is the left. This is 4. This is x square plus 4ax plus 4a square. Multiply it with 4, that is 4x square. 16ax plus 16a square. This is 9x square minus 6ax plus a square. 9 minus 4 is 5x square. Minus 6 minus 16 is minus 22ax. A square minus 16, that is minus 15a square, is greater than 0. That's the quadratic inequality you get. Now 5 into 15 is 75. 25 into 3. So 5x square. And this is minus 25ax plus 3ax minus 15a square is greater than 0. Take 5x common out. This is x minus 5a. Double check. That's correct. And this is 3a common. and this is x minus 5a. This is greater than 0. X minus 5a, 5x plus 3a is greater than 0. Draw a number line. Draw a quadratic curve like this. Label the roots. X comes out to be positive 5a. X comes out to be negative 3a over 5. Negative 3a over 5. These are the two roots that you get. Now, the scenario is, since we are looking for greater than 0, therefore you end up with two answers. One to the right, extreme right, and extreme left. Extreme right, x is greater than 5a. Extreme left, x is lesser than minus 3/5 a. So write both the answers with a comma sign in between. X is lesser than minus 3/5 a, comma. X is greater than 5a. So therefore, this is the answer for question number 2. Let's move to question number 3. Question number 3 says complex numbers. That means this is a question of complex numbers, that's for sure. So this is, let me just adjust the radius. This is complex numbers. And which aspect of complex numbers is this? This looks like algebra. The other one also looks like algebra. So the algebraic aspect of complex number. It says u is equals to a plus ib. U star, let me write it right away, a minus ib. W is c plus id. W star is also needed, that is c minus id. What else is needed? U plus w. So therefore, this thing, the left hand side, if I say so, u plus w is a plus c, add the real to the real, and b plus d with a positive sign, that is u plus w. U plus w, the whole thing star, that is a plus c, remains as it is, and b plus d has now a minus sign on the outside. So this is your left hand side of this equation. And u star plus w star, u star plus w star, that is u star, that is w star. So this is a plus c minus ib minus id. Therefore, this is a plus c, put it in bracket, take minus common out, b plus d with an I on the outside. So this is the right hand side of the equation. So this is the right hand side. I have proven the left hand side equals to the right hand side. So it's just basic stuff. Part B. Solve the equation z plus 2 plus I, the whole thing conjugate, is 2 plus I multiplied by z equals to 0. Give your answer in this form. Now in this scenario, first of all, write let z is equals to x plus iy. Therefore, let me start working on the left hand side. X plus iy plus 2 plus I. I'm first evaluating this. It's actually not the left hand side. Actually, everything is the left hand side. This is basically, let me highlight it, this part of the equation. I'm focusing on this one. So now write the x with the 2 and the iy, this is I plus iy, that is the next part. This is the first part without the conjugate. Now let me write a conjugate on the outside. Let me write a conjugate on the outside. What will happen? This plus sign will become a negative sign. So therefore, this is x plus 2 minus 1 plus y, and the coefficient is I. This is what you get on the first part. Similarly, this second part, let me change the color for later. This second part, 2 plus I multiplied by z. Let me multiply this out. So this is 2 plus I multiplied by z. Z is x plus iy. So this is 2x plus 2yi plus ix plus I square y I square is negative 1. So this is 2x minus y. And this is 2y plus x. This is the coefficient of I. This is the second part. Now there is a plus sign in the middle. So now you add it up. So therefore overall is x plus 2 plus 2x minus y. I'm adding the real to the real. So let me highlight it more. This is the real. This is the real. That's the real part. So real, real. And since it equals to 0, in other words, this is 0 plus 0i. So the real part is 0. So these are the real coefficients that I'm talking about. X plus 2x, that is 3x, minus y plus 2. 3x minus y plus 2 equals to 0. Therefore, y is equals to 3x plus 2. This is the equation that will be of use to us. Let me call this thing as equation number 1. So this is equation number 1. Similarly, the second part, that is the imaginary, and this is the imaginary. So imaginary plus imaginary, let's add it up. That is 1 plus y with a negative sign. Don't forget this negative on the outside. Plus sign, this is 2y plus x. Again, the imaginary part is also 0. So therefore, minus 1 minus y plus 2y plus x equals to 0. So 2y minus y, that is y. And minus 1 plus x is basically 1 minus x. So this is the second equation that you get. So let me just take this down for this to be the second equation. So therefore, they both are equal to y. So therefore, 1 minus x is equals to 3x plus 2. Therefore, 4x is equals to 1 minus 2, which is negative 1. Therefore, x comes out to be negative 1/4. Y is equals to 1 minus x. Y equals to 1 minus 1/4, which comes out to be 5/4. Therefore, the complex number z is x plus iy. Therefore, minus 1/4 plus 5 over 4i. This is the final answer for this particular part. Again, very, very basic knowledge. So first the real with the real, and then the multiplication and conjugate and all these things. So that was all applicable. In the second part, actually, multiplication was not there. It was simple addition. Except for a little multiplication over here, just a little one. Now, question number 4. Question number 4 is only one part. Normally, partial fractions comes out with either binomial or integration, but for some reason, it's just simple partial fraction. So now, start thinking very, very carefully. First of all, the doubt that I had that what this question will be all about, that is, it's an improper fraction. So it's an improper algebraic fraction. Highest power in the numerator is square, highest power in the denominator is square. The divisor, that is 2x minus 1 multiplied with x minus 3. Multiply it out. 2x into x, 2x square minus 6x minus x plus 3. That is 2x square minus 7x plus 3. That's the first part. That is, you can say, step number 1. Step number 2 is long division. So algebraic division, that is, what do you have as the numerator? 4x square minus 13x plus 13. 4x square minus 13x plus 13. And what do you have as the divisor? Let me just write it like this. Your divisor is answer of step 1, 2x square minus 7x plus 3. 2x square minus 7x plus 3. Let's start off. So now we have the first term, that is 4x square. So this is 4x square, this is 2x square. You divide, you get 2. Just a constant because the powers are equal. So 2 multiplied by 2x square, that is 4x square, minus 14x plus 6. Put a line over here. That's too much of a thick line. Change the sign. So therefore this is minus and this is a plus and this is a minus. Make it prominent. So minus 13 plus 4, that is minus 9x. 13 minus 6, that is plus 7. Therefore the quotient is 2. The remainder is 7 minus 9x. You can write it like this. The divisor is this quadratic, which is 2x minus 1, x minus 3. 2x minus 1, x minus 3. This is the factorized form. And then you write this thing as quotient plus remainder over divisor. Quotient is 2, remainder is 7 minus 9x, and the divisor is 2x minus 1 and x minus 3. So now the partial fraction working will be for this thing. So partial fraction will now be based upon this thing. So here comes step number 3. So step number 3, that is 7 minus 9x over 2x minus 1, x minus 3 is identical to a constant over 2x minus 1, another constant over x minus 3. Take LCM. 7 minus 9x is identical to a multiplied with x minus 3 and b is multiplied with 2x minus 1. Let us choose x equals to 3 because a will disappear. 9 3s are 27. 7 minus 27 is negative 20. And 2 into 3 is 6. 6 minus 1 is 5. That is 5b. Therefore, b comes out to be negative 4. Choose another one. Let x equals to half. So when x equals to half, 9 into half is 4.5. 5, that's 2.5. So this is 5 over 2. This is 5 over 2, negative or positive? This is positive. Therefore, half minus 3, that is minus 5 over 2a. So do double check at the end. A comes out to be negative 1. So b comes out to be negative, and then a comes out to be negative 1. So therefore, I'm just double checking it. First of all, let me check for this thing. That is the denominator, which is 2 plus something. So now this is 2x minus 1 and x minus 3. 2x minus 1, x minus 3. A is multiplied with x minus 3. B is multiplied with 2x minus 1. When we choose 3, so 9 into 3, 27. 7 minus 27 is minus 20. That is perfect. 2 3s are 6. 6 minus 1 is 5. So therefore, b comes out to be negative 4. Now let me just double check. Is there any mistake for this one? 13 minus 13 plus 14 is not minus 9. I just had a doubt about that because the answer was some kind of like different for me. Minus 13 plus 14 is simply x. So this is simply x, and therefore let me correct myself from this step onwards. So sometimes you get this awakening in your heart that something is wrong. So therefore this is like this: 7 minus x, quotient, remainder, divisor. Therefore this is 2 plus 7 minus x divided by 2x minus 1, and this is x minus 3. Now this is what partial fraction is all about. So that brings us to step number 3. So step number 3 is 7 minus x and 2x minus 1, and x minus 3 is identical to a over 2x minus 1 and b over x minus 3. And 7 minus x is identical to a times x minus 3 and b times 2x minus 1. Let x equals to 3. 7 minus 3 is 4. 2 into 3 is 6. X is 3. So this thing disappears. 2 3s are 6. 6 minus 1 is 5. This is 5b. I think there are no fractions in this one. So I think I made some mistake. 4x squared, that is 2. Minus 14x plus 6, that makes sense. 13 minus 6 is 7, that makes sense. And now this is another mistake, that is plus x. So this is plus x, this is plus x. This is plus x, 7 plus 3, that comes out to be 10. So now let me correct it. Therefore, now it's making sense. Therefore, B comes out to be 2. Now, next one, let x equals to half. So let x equals to half. Therefore, 7 plus half is 7.5. And half minus 3 is minus 2.5a. Therefore, a comes out to be negative 3. Therefore, final answer, step 4, that is the final answer, that is 2 plus something over something and something over something. So a is minus 3, so therefore you need a minus over here. This is 3 over this thing, plus b is 2, that therefore this is 2 over x minus 3. So make sure that you write the answer in the fraction form. So this is the final answer for this particular question. So we made some mistake, and that was about plus and a minus. Question number 5. Let's get started. Question number 5 says, on a sketch of an Argand diagram, shade the region. So the first of all, this question is about shading. Whose points represent the complex number z satisfying the inequality such and such. Second part, greatest value of argument of z for points in the shaded region. Give your answer in degrees. First thing first, that is, you need to draw this thing, that is z minus 3 plus 2i modulus is less than or equal to 1. It's a circle. The center of the circle is 3, 2, and the radius of the circle is 1 unit. That's the first thing. So somewhere this is like 1, this is 2, this is 3, this is I, this is 2i, this is 2i, this is I, this is 1, 2, 3. And then this is the real part, and then this is the imaginary part. And you draw a small circle without any shading for right now. And this is 2, 3. So I need one more thing. That is 3, 2i. So 3, 2i, this is the center. And you need a circle like this of radius 1 unit. So basically this is like this and something like this. That's the circle that you get. It doesn't have to be accurate. So now this thing is, let me just shift this thing a little bit like this. And let me resize this and let me make it a little bit smaller. Okay, that's the circle, looks perfect. And then it says imaginary part of z. Imaginary part of z is greater than or equal to 2. Imaginary part means y. Y is greater than or equal to 2. So draw the line y is equals to 2. That means 2i. So this orange line, I'm drawing it like this. This is the line y equals to 2. Let me adjust it. So therefore this is y equals to 2. Region above the line. So therefore when you will shade it, this is the answer for the shaded region. So therefore let me make it thicker. This one over here, that is above, that's like half of the circle. That's like a semicircle kind of thing. Now it says find the greatest value of arguments of z for points in this region. Now first of all, in order to draw that argument of z, first of all it has to be a half line, and this half line will be making a tangent somewhere over here. So basically I'm interested in this angle. Let me call this thing as theta. Argument of z, it's a half line, and it's a half line whose starting point is the origin 0, 0. Now how do I find this angle? So let me label something. Let me label this as O. Let me label this point as A. Let me join it like this. This is center C. And let me join it like this. That is OC. So first of all, OC, that is O is 0, 0. C is 3, 2. OC magnitude, that is 3 square is 2 square under root, that comes out to be root 13. And AC magnitude is the radius. AC magnitude is the radius, which is 1 unit. So therefore, uh, I am looking for this small angle. Let me call this as beta. So sine of beta is equals to 1 over 13. In other words, beta is sine inverse of 1 over root 13, whatever that comes out to be. This thing is done. Now can I find this angle, and this theta is the whole thing, and let me call this angle as, let me mark it in blue, let me call this angle as phi. How can I find phi? Draw another triangle. So this is OC and D. So when we talk about OCD, so this is like this. This is a line, and then a line like this, and then a line like this. So this is O, this is D, this is C, this is 2, this is 3, and this is phi. So tangent of phi is 2 over 3. Therefore, phi is tangent inverse of 2 over 3. So these are the two angles that you get. Let me move it somewhere over here. So you have beta, you have phi. When you look at the diagram, let's look at it. This theta is the whole thing. So this theta is basically phi plus beta. So this theta is basically beta plus phi. So this is sine inverse of 1 over root 13 plus tangent inverse of vertical is 2 and horizontal is 3. So this is 2 over 3, and then you get this answer. And now you can use a calculator, and that's your answer.